Section 2.4 is on page 165, talks about sequences and summation. So we just want to introduce this lightly. A sequence is a function from a subset of set of integers, usually either 0, 1, 2 all the way up, or 1, 2, 3 and all the way up. We use the notation a sub n to denote the image of the integer. We call a sub n a term of a sequence. Now, easier definition to remember: a sequence is a list of numbers. That's really simple to remember, with no correlation whatsoever. It might have a correlation, maybe not. It doesn't matter. Any list of numbers is considered a sequence. Here it says, so a sub n is listed like this normally. What is the 8th term of the sequence? So part A, if a sub n, this general term, that's what we call it, the general term of the sequence is 2n minus 1. What is the 8th term? That is 2. 8 minus 1 is 7. You could leave it like that. You could multiply it out. If you're allowed a calculator on a test, you work it out. Otherwise, you leave it like that. B. If I take a sub n to be 7, so this is a constant function. Any term is going to be 7. It doesn't matter. This is like saying y equals 7. Whatever x is, y is 7. Here, a sub n is 1 plus a negative 1 to the n power. So a sub 8 is 1 plus a negative 1 to the 8th power. That's simply 2. And this sequence, you're either running 0 or 2. And if a sub n in part D is minus a negative 2 to the n, then a sub 8 is minus a negative 2 to the 8. That's basically negative 2 to the 8, or you could say that's negative 128 times 8, 256. 128 times 2, yeah. There it is. Now, we talk about a geometric and arithmetic sequence. Those are the two most common used sequences. A geometric progression is a sequence of the form where you multiply by r every single time to get the next term. And the general term is the first term times r raised to the n minus 1, where r is the common ratio. R, you take any term divided by the previous term. If you're dealing with an arithmetic sequence or progressive sequence, that's when instead of multiplying, you add a d every time. And that's where the arithmetic name comes from. And the general term is a sub 1 plus n minus 1 times the common difference, where d is any term minus the previous term. Now, they want us to list a few terms. They want us to list first, second, third, fourth term, where this is a sub n. So if a sub n is negative 2 to the n, then a sub 0, well, anything to the 0 power is, other than 0 of course, is 1. A sub 1 is negative 2. A squared, negative 2 squared is a 4. And a cubed is negative 8. So if you look at the list, 1, negative 2, 4, negative 8. Do you see here that you are multiplying every time by a negative 2? So this is a geometric sequence. Now, if I look at B, well, the same deal in B. A sub n is 3, it's fixed. So a sub 0, that's 3. So if I want the list 3, 3, 3, 3, this thing never changes. It's constant. If I take C, a sub n is 7 plus 4 to the n. So a sub 0 is 7. A sub 1 is 11. A sub 2 is 16 plus 23. A sub 4 is, A sub 3 is 7 plus 4 to the third, that's 64. So this list consists of 7, 11, 23, and 71, and the list goes on. And if I go for the last piece, so this is not arithmetic nor geometric, A sub n is 2 to the n plus negative 2 to the n. So A sub 0 is 2 to the 0 plus 2 to the 0, that's 2. A sub 1 is 2 to the 1 plus a negative 2 to the 1, that's 0. A sub 3 is 2 cubed plus a negative 2 cubed, that is, okay, A sub 0, A sub 1, A sub 2, that's what I meant. That is 4 plus 4, which is 8. A sub 3 is 2 to the third plus a negative 2 to the third, that's 8 minus 8, which is 0. So this sequence consists of 2, 0, 8, 0, and the list goes on. Now, a recurrence relation, we call it recursive most of the time, for a sequence is an equation that expresses A sub n in terms of one or more previous terms. I'll tell you what that means in a minute. So on the previous problems, if I wanted A sub 100, I just replace n by 100 and figure out what that term is. On number 4, if I want to find A sub 100, I replace n by 100, and that will tell me the actual form. This is what this says. This says, if you want to find the term, take negative 2 times the term before it. And the first term is negative 1. So just to keep how simple this is, if this is a term, the next term is A sub n plus 1, and the previous term is A sub n minus 1. So if you start reading it this way, next term, previous term, to find a term, take the previous term multiplied by negative 2. They want us to find the first six terms. Well, the first term is a negative 1. The second term, if you want to use the formula, you would take negative 2 times the previous term, which is 2. The next term you multiply by a negative 2, that's a negative 4, that's an 8, that's a 16, and that, negative 16. And that will be a positive 32. And these are 2, 4, 6 terms. The deal here, if I want to find A sub 100, I need negative 2 times the 99. So to find the 100th term, I need to list the first 99 terms. Versus here, I just replace n by 100 and I'm set. So recursive depends on prior terms. Same deal here. Here it says, if you want to find any term, take the previous term, square it and multiply it by 3, and they give you a starting point. They say, well, start with 1. The next term, 3 times 1 squared is 3. So if I want to go by A sub 1, that is 3 times A sub 0, but A sub 0 is 1 squared, and that will be a 3. A sub 2, that would be 3 times A sub 1 squared, that's 3 times 9, which is 27. And the next term, they want 6. So do you notice that your A sub 3 is 3 times the previous term squared, that is 3 times 27 squared, that's a big number, and then A sub 4 is going to be 3 times the previous term squared, and there they are. You have a calculator, you multiply that out. You don't have a calculator, you leave it as is. On the exam, either will be accepted. And here's to find any term, take the term before it and subtract it from the term before and add it to the term before. And here they have to give you at least 3. So here to find, we have 1, 1, 2. Now, to find a sub 3, that is, according to this, the term before it minus the term before that plus the previous term. A sub 3 is 1 minus 1 plus 2, which is 2, of course. There it is. A sub 4. Take a sub 3, subtract a sub 2, add a sub 1. So that is a sub 3 is a 2 minus a sub 2 is a 2 plus a sub 1, which is a 1, so that's 1. 1, 2, 3, 4, 5, one more. A sub 5 is a sub 4 minus a sub 3 plus a sub 2. A sub 5 is a sub 4 is a 1 minus 2 plus 2, so that's a 1. And here they are. Now, Fibonacci numbers are extremely useful for growth of plants, trees, branches, and this is what it says. It says to find any term, take the term before it and add it to the term before that. And you start with a sub 0 equals 0, a sub 1 equals 1. So the Fibonacci numbers are, start with 0 and 1. Add those two, you get a 1. Add those two, you get a 2. Add those two, you get a 3. Add those, you get a 5, 8, 13, 21, 34, and the list goes on. These are the famous Fibonacci numbers. They model a lot of applications. Now we get to find the general term. So find the term that generates the sequence. That's what they want. You notice here you're adding 4 every time. So the general term is really a sub 1 plus n minus 1 times the common difference. And in this case, a sub n will be the first term is a 7, it's right there, plus n minus 1. And what are you adding every time? Aren't you adding a 4? So a sub n is 4n minus 4 plus 3. There it is. We're assuming here that you start at 1. So here we're assuming you're looking at a sub 1, a sub 2, a sub 3, and the list goes on. It says, assume that your format or rule is correct. Determine the next 3 terms of the sequence. Okay. A sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, 7, 8, 9, a sub 10. We want a sub 11. That's simply 4 times 11 plus 3. That's 44 plus 3, 47. So the next term on the list is 47. A sub 5, that's a sub 12, will be 4 times 12 plus 3. That is 48 plus 3, which is 51. And if you want to find a sub 13, that's 4 times 13 plus 3. That is 52 plus 3, which is 55. And there it is. Now, if you look at D, you notice you're multiplying by a 2 every time. So the general term is the first term times r raised to the n minus 1. The first term is a 3 multiplied by 2 to the n minus 1. There it is. 1, 2, 3, 4, 5, 6, 7, a sub 8. Again, we're assuming this is a sub 1. That is 3 times 2 to the 7th. Right? You have a calculator, you work this out. You don't have a calculator, you leave this alone. That's not an issue. To me, those are the same. Now, in the back of the book, most likely they multiply those. So on the homework, you should do that. But for the test, it doesn't really matter what do you do with this. So Alright. Oh, I keep forgetting what they want us to find. Next three terms. A sub 9 is 3 times 2. Well, this is always 1 less than that. And the next term, a sub 10, is 3 times 2 to the 9th. And there it is. Again, you can multiply this with a calculator with ease.